Welcome to the part 4 of this video series. In this video series, I'm explaining how to use large language models to create web applications. In part 1, we looked into the design aspects, and in the part 2, I showed the actual process of designing the prompt template, and also we looked into the process of creating custom data. In part 3, I explained the fine tuning process using the custom data we created in the part 2. In this video, we will be using the fine-tuned version of the large language models to do the inferencing, and also we look into the response generated by the large language model, and then we look into how to format the response in a such a way that we can use in our web application. Here is my Visual Studio Code. I will explain the code which I will be using to do inferencing on the fine-tuned large language model. Let me explain the code. Before we start inferencing, we should import auto model for casual LLM and auto tokenizer. These two are coming from the transformers package provided to us by the Hugging Face. Auto model for casual LLM is used to load the large language model, and we can also pass bits and bytes configuration to it so that we can quantize the large language model. And auto tokenizer is used to create a tokenizer for whatever the large language model we are loading. We should use the pipeline function, and this pipeline function is used to do the actual inferencing of the large language model. Then we have to use PEFT model class, and the main reason we are using PEFT model class because we used PEFT to fine tune the large language model. At the end of the fine tuning process, we will have an adapter class, and we need to use that adapters and combine with the base model of large language model to do the inferencing. And to achieve that, we need to use this PEFT model class. And if you see here, these two are the variables. The first variable is the location of the base model where I have downloaded. I'm using Mistral-7b. And the PEFT model, this is the location where the fine-tuned adapter is saved at the end of the fine-tuning process. Okay, let me explain this piece of code. This piece of code I'm using to load the large language model, and I'm giving the location of the base model. I'm telling the device map is auto, which means the class auto model class is responsible for splitting the large language model based on the resources I have. In my case, I have two GPUs, so the large language model will be distributed on the two GPUs. And I'm specifying the D type as B float 16. The reason for this is Mistral and also Llama 2 both are pre-trained on the B float 16 floating point, so that's the reason I'm using it here. And trust remote code false, you should use this false almost all the time, and there are few scenarios where we use this as true, and those scenarios are like if the large language model is very new and the Hugging Face don't have any information about the architecture. When you put true here, it tries to fetch the architecture information from the remote. That's what it does. But in our case, I'm using Mistral-7b. Hugging Face has the information about this architecture, so I'm using false. And this one, I don't have to use it. It doesn't make any sense to use it here because I am loading the large language model from my local. But let's say you are loading the large language model from the Hugging Face hub, then you can specify the branch you want to load from. All right, the this piece of code is just to create a tokenizer for the whatever the large language model we are using. I'm using Mistral-7b, so I'm passing the location of my Mistral-7b, and based on the configuration files inside this location, it will create a tokenizer. Next, there I'm creating a PEFT model. Like I said before, we have to use this PEFT model class because we have a base model which is a Mistral-7b, and I have an adapter which is saved in this location. So now I have to combine these two to create a response from the large language model. And to do that, we have to use this PEFT model class and pass the base model and also the location of the adapters saved. Then we should create a pipeline. Okay, let me explain the pipeline function. The first parameter we are passing is a constant value text generation because I'm only generating the text. There are many possible values. Let me show you the values. So if you see here, there are many different values which we can pass, and I am passing the text generation. But in if your use case is not just a text generation, but let's say it's a question answering, you can pass question answering, and if it's summarization, you can pass summarization. In my case, I'm using text generation, and I'm passing the PEFT model because I'm not doing inferencing on the base model. I'm combining the base model with my adapter, and then I want to do inferencing on it. So I'm passing the PEFT model, which I have created in this line. Then I'm passing the tokenizer, which I created here. Then I'm specifying that the max new token should be 2000. I'm expecting the new tokens should be around 2000. That's the reason I'm giving 2000. But if in your use case, if 2000 is too much, you guys can change it to 250 or 500. But in my case, 2000 is what I am expecting. Then all these are the hyperparameters. For now, let's keep temperature 0.7, top P as 0.95, top K as 40, and repetition penalty is 1.1. I have a separate video explaining these values. You guys can check that out. Then here I'm creating a prompt template. This is the exact prompt template which we created in part 1 and part 2, and this is the same prompt template which I use to fine tune the large language model. If you are following my part 1 and part 2 and part 3, you should be familiarized with already. And here if you see, I'm saying the name of the dish he is here, this one. So right now I'm just giving the dish here, but in real world application we will replace the dish name, and we will also replace all the formatting objects. But for this demo, let me put a dish name here and also put the formatting data here. And if you see here, the response is empty. When we are doing the fine tuning, we have provided the response as well and then did the fine tuning, so the large language model knows what to predict after it sees the response special token. So now because we are giving an empty here, now the large language model is already fine tuned on this data. It knows that as soon as sees this response token, it knows that it has to generate something, and it predicts what it needs to be generated based on the fine tuning, and it will print. All right, so this is the prompt template, and let me run the large language model and show you what's the response we are receiving. So this is a cell which is running or doing the inference of the large language model. So let me explain this code a bit. The first line, if you see here, and this is the pipe variable which we created here. So this pipe variable will take a template as an input, and it does the inferencing. And then after it does inferencing, this is the line where we are actually pulling the actual response out of the pipe output and then printing the response. So let me run and show you how the response looks like. All right, let me run all the cells until here so that you can see how the response looks like. So this cell, whatever I'm running here, it is loading the large language model onto my GPU. It's done. It took 4.5 seconds to load. And this cell, I'm just creating a variable with the prompt template, and which is having a dish name and the formatting object. And this cell, which actually does the inferencing and pulls the response out of the pipe output object and then prints the response. Let's see how the response looks like. All right, we got the response and it took around 2 minutes to generate the response. And let's see the response we received from the large language model. If you see here, we received the response the way we are expecting. That's in the JSON format. And this is the dish name, the cuisine. It gave the preparation time, cooking time, equipment list, ingredient list, instructions. So this is the exact way we want, and the reason we received the way we wanted is because we fine-tuned our large language model. And you can see there's a lot of other text generated which we are not interested in, but the reason you see all the other text because we gave a max token as 2000. So our large language model knows that it has to generate until here, and after that it just generated some random text. But that's okay because we can get rid of all the unnecessary information which large language has given to us. Okay, so let me show you what happens if I remove the adapter. Let the PEFT adapter and let me rerun again. So I'm gonna restart all the variables, and now I will be rerunning, but this time what I'm gonna do is I'm gonna comment out this PEFT model, and I'm not gonna use the PEFT model. I'm gonna use the base model from here and paste it here, and let me run it. All right, it took 4 seconds to load. Now let me run the prompt template and let me run the response again. It might take another 2 minutes. All right, we got the response. It took around 2 minutes. And if you see the response which we received from the base model is not what we were expecting. Um, this is the complete response we received, and none of this is what we are expecting. So let me put back the PEFT adapter and let me rerun again, and this time let us change the name of the dish to see how does it work with the new dish. All right, I restarted the variables. Let me uncomment this line, put the PEFT model back here, and let me rerun. Okay, it took 4.5 seconds to load. Now let me load the prompt template, but before loading, let me add a name of the dish. I'm not sure which dish to add. Let me ask Chat GPT or any random dish. So I'm asking a random dish name from the Irish cuisine. In my fine tuning process, I did not include any Irene cuisine dish. Let's see how the application or let's see how the large language model responds for this dish name. Okay, I have loaded the variable, the Mistral prompt template variable, and let me rerun the inference again. All right, we got the response from the large language model, and if you see, this time the response is as expected. Let us analyze the response a little bit more. If you see, it starts with the prompt template which we have used, and just as we expected, the large language model is predicting what it's need to generate after the special token, which is the response special token. And the response which it generated is what we are expecting. And if you see here, the name of the dish is called Canon. Cuisine is Irish. It provided everything: preparation time, cooking time, equipment list, ingredient list, and instructions, just as we wanted. But there is something we need to also see here is it also generated some random text, and that's because large language model does not know where to stop, and we have provided 2000 max tokens. So whatever it has to do, it will print until the max tokens, that is 2000 max tokens, is reached. But that's not a problem for us. We can easily filter it out. We can remove this text, and we can also remove the text from the top. So let us go one by one how to refactor or how to reformat this response in such a way we can use it for our web application. We know that the response which we need or the useful response is this one. Only the JSON objects, all the JSON objects within the JSON array, right? We don't need the top part. We don't need after this JSON array. So we need to somehow remove this. So I have created some custom functions. It's not me who wrote the functions. I asked ChatGPT and ChatGPT provided the Python code. And let's see the Python code. So before seeing the Python code, we should understand that what exactly we are aiming for. And my aim is to remove the text, the starting text until it hits this response. So I asked ChatGPT the same thing, that I need a Python code which can remove a text from the starting until it hits this tag. So ChatGPT gave me a response with the function, and let me show you that function. This is the function which ChatGPT provided to me, and if you see here, this function takes the input string and it splits the string based on this response special token, and after that it just returns the cleaned part. So let me run this and let me take this response and let me rerun by, let me print using the function which ChatGPT gave it to me. Okay, this function is provided by ChatGPT. Let me see what it does. So if you see here now, this function removed the top part of the line or the text, right? So this is what we want, but at the same time, we also want to remove this part from the bottom. Now, this time we need to remove the data or the text from the bottom until it reaches these two characters. So I asked ChatGPT the same thing and it came up with a function, and let me show you that function. So if you see here, remove until brace, this is the function which actually removes until it sees these braces. At the same time, I also asked ChatGPT, just to be in case that if it sees a JSON object without this bracket, I asked ChatGPT to create a function which can replace or which can add this one on the top and which can add this one on the bottom. So ChatGPT gave me two functions, one which adds process string last character and process string first character. So this function, what it does is, let's say in the response, if I don't see this part, then it adds this one, this bracket, the square bracket, open square bracket. And also in the end, if it doesn't see that, it will add another square bracket so that it creates a valid JSON object. Okay, if you see here, I have combined all the functions provided to me by the ChatGPT. Let me explain what I did. I chained all the functions. The first function, if you see here, it removes all the text from the start of the text until it hits the response tag. And then whatever the output I received, I'm passing into this function, which removes from the bottom of the text until it sees the braces. Let me explain what I mean. When I say the braces is, if you see here, from the bottom all the way until the braces here, and then next I am passing that value into this function, and this function, what it does is it processes the last character of the text. If it doesn't have the square brackets, it adds the square brackets. If it does have the square brackets, it just ignores it, and whatever the response I receive from here, I'm passing into the another function which actually checks if the first character has a square bracket. If it does not, then it will add the square bracket. If it has, it will not. So let me run this, and I'm adding this payload into a file, into a test1.jsonl file. just to show you guys how the response would be. Okay, if you see here, I have executed this cell, and also at the same time, it created a file here, the test1.json. Let me open this. If you see here, this is a JSON object which our application created. And the idea is this JSON object should go into the data store. In our case, we are using the Couchbase database. But let's say for now, for this demo, just forget about the Couchbase. Let's say this is our data store and this is how the data will be stored. Okay, if you see here, it is just an array of objects with title, and the formatting information, and the cuisine and the formatting information. So what I can do is I can just copy this and show you guys how this can be used in the web application. Let me run the web application and I will show you how it will be printed as a blog page. So I'm starting the web application, and this web application is built on Next.js. So Next.js is running. So I have created this component. So let me replace this with whatever we just created. So this is what we created just now. Our large language model has created this one. The idea is this JSON data comes from a REST API, and that REST API actually pulls the data from the Couchbase. But for now, we don't have a Couchbase, so I'm directly adding this data into this JSON data variable, and let's see how it is displayed on the blog page. And if you see here, our data is printed including, our data is displayed including the formatting information. So now let's say you want to change the format of instructions or maybe ingredients. I'm not sure, but let's say you want to change the format of instructions. So now what you can do is we can go to our large language model template, which is here, and we can change, or we can tell large language model what the formatting should be for the instructions. So this is the format object of the type instructions have these values. And if you see here, because this is bold true in our application, you see it is bolded, and it says italic false. That's why it's not italicized. So now let's flip this, false for the bold and italic is true. And then let's increase the font size for whatever the reasons. Let do this 24, and the font color, so let us keep the font color of equipment list and the font color of instructions the same. This is just to show you guys that large language model is working, or the large language model is creating the content and the format data based on our instructions. So if you see here, what I did is I'm saying the instructions should have this color, font color, bold is false, italic is true, but the same color is also present for equipment list. If you see here, the equipment list, it's the same color. So now let us rerun the inference and see how the response is. All right, I got the response from the large language model, and let's see how the response is. So the response is as expected. Again, we have the top text to remove and we have the bottom text to remove. And let us run this text through those functions and save it in a file and then use it in the blog page component. Let me run this cell where it actually formats the response which we received from the large language model. And this time I'm saving the data in the test. Let me run test3.json. So this response we should be seeing in the file called test3. If you see here, there is no test3. Let's run and see. So test3 has created. Let us copy this and let me go to the blog page. Let me replace the old content, and now let us look in the blog page. All right. So if you see here now, it's not bold anymore. So the bold is not there, it is italics, and the color, the font color of equipment and this one is the same. So we know that our large language model is following our instructions as expected. It is providing the JSON response as we want, and we our custom functions which we built also working as expected, because we can now just take the data which is saved in the file, in the JSON file, and use it in this JSON data which is part of the blog page component built on the Next.js. And when we rerun it, when we refresh it, you see the formatting is changed. So in this video, we looked into the inferencing, we looked into the way we can process the response from the large language model. We changed the dish names to see if the large language model, the fine-tuned version of the large language model, is working as expected. We also changed the formatting information, and we see that our large language model is responding as expected. And that's it for this video. Thanks.